We're going to continue our discussion in chapter 1, linear functions, equation, and inequality. Equations of lines and linear models. Point slope form of the equation of a line. We have y is equal to mx plus b for the equation of the line with the slope of m and the y-intercept of b. We call this slope-intercept form. Now we're looking at different form. We call these point slope form because we have the slope here and what's given to us a point x1 and y1. Using point slope form, if I have 2 points, I should be able to use this information to write the equation of the line. The first thing I need is the slope. You recall slope is equal to y2 minus y1 over x2 minus x1. We're going to label these points point 1 and point 2. And y2 in this case is 7. So that would be x2. x2 is equal to 1. y1 in this case is equal to 3. So this would be x1, y1. So we're assuming this would be my point 1. This would be my point 2. Again, doesn't matter which one you want to call point 1, which one you want to call point 2. Once you decide that and label the points, you can substitute the values into this formula to solve for the slope. Slope is minus 2. Now, if I substitute for each m minus 2 and pick either of these 2 points and substitute that for x1 and y1, I can get the equation of the line. Again, you can pick either of the points. If I assume point 1 is 1 and 7, so this time this would be x1, this would be y1. Everywhere I see x1, I'm going to substitute 1. Everywhere I see y1, I'm going to substitute 7. And then I can solve for y to write the answer in slope-intercept form. So this is my line. Slope is minus 2, means from every point on the line, if I go down 2 units and 1 unit to the right, I get back to the same line. So from this point, if I go two units down and 1 unit to the right, I get back to the same line. Or if you think of a slope being 2 over minus 1, which is the same as minus 2, if I from every point on the line, if I go 2 units up and one unit to the left, I get back to the same line. So if I from every point on the line, if I go 2 units up and 1 unit to the left, I get back to the same line. That's what it means, the slope being minus 2. Using point sloped form, the table below shows a list of points found on the line. Find the slope intercept form of the equation of the line. So we can pick either of these set of points to find the slope. So looks like we are looking at y2 minus y1 over x2 minus x1. So we're looking at this point here being your y2. And then we're picking this point here being y1. So we're picking this point, my point 1, 2, and 3. So this would be x1, y1. I'm picking this point here being point 2, 6, and 11. So 6 is x2, and y2 is 11. So you substitute the values here, and you can see you can find the slope. You could pick any of these points to find the same slope. Now I can use the formula y minus y1 is equal to m times x minus x1. Again, I can pick any points, call it point 1, and substitute that in this formula. So it looks like we're picking this point here being point 1, and substitute for each y1, 3, and for each x1, 2. And that would be my equation of the line. If I want to write this in y is equal to mx plus b, I need to solve for b. So if I distribute the 2 and add 3 to both sides of the equation, I get y is equal to 2x minus 1. It means my slope is 2 and my y-intercept is -1. Standard form of the equation of the line. So far we looked at y is equal to mx plus b. We also look at y minus y1 is equal to m times x minus x1. And we call this slope-intercept form, and this was slope point form. Now we have another one called standard form, which is ax plus by is equal to c, where a, b, and c are real numbers, and this is the standard form. Graph an equation in standard form. 3x plus 2y is equal to 6. Best point to look for would be x and y intercept. So if I let x equal to 0 and solve for y, I would get y is equal to 6 over 2, which is 3. So I can see my y-intercept is 0, 3. This is where my line is going to intercept y-axis. If I let y equal to 0 and solve for x would be equal to 6 over 3, which is equal to 2. So this would be my x-intercept. This is where my line going to intercept x-axis. If I connect these 2 points together, that would be the line. If you want to graph 3x plus 2y is equal to 6, graphing calculator. So in this case, I can solve for y by subtracting 3x from both sides of the equation, divide each term by 2. This is what do I get for y in terms of x. This is how I can enter the equation into my calculator, and you can see the graph on your calculator. Parallel lines. If you have 2 lines that are parallel, the slope would be exactly the same. Using the slope relationship for parallel line, I'm going to find the equation of the line that passes through the point 3 and 5. So we know 1 point. And we don't know the slope, but it says, and it's parallel to the reference line. This is my reference line. My line is parallel to this. If I find the slope of this line, the slope of my line would be exactly the same because they're parallel. To find the slope of any line, the best way would be to simply solve for y. Once I get it into the form y is equal to mx plus b, the coefficient of x would be your slope. So the slope of the reference line, the parallel line, would be minus 2 over 5. That's the same slope as my line. So my line also have the same slope of minus 2 over 5. As you can see, once we write the equation in slope-intercept form, just by looking at the equation, we can see the slope is the coefficient of x and the y-intercept is the constant, which is 4 over 5. Using the slope relationship for parallel lines. So in this case, we can use point slope formula. Y minus y1 is equal to m times x minus x1. We pick a point. We substitute for each x1, 3, for each y1, 5. That's a given point. And the slope is minus 2 over 5. And if you just simply solve for y, you would get the equation of the line. As you can see, you can use your graphing calculator to see both lines being parallel. Perpendicular line would be when two lines are perpendicular, the relationship between the slope would be if the slope of one line is a over b, the slope of the other line, if they're perpendicular, making 90 degrees angle, would be negative and reciprocal of that. So if the one is a over b, the other one would be minus b over a. The product of their slope would always be equal to -1. So if two lines are perpendicular, if you multiply their slopes, would always be equal to -1. So that means if the slope of one line is a over b, the other one would be negative and reciprocal of the other one. Using the slope relationship for perpendicular line, find the equation of the line that passes through the point 3,5 and is perpendicular to this line 2x plus 5y is equal to 4. So I know one point. That's what I need to write the equation of the line. Now I also need the slope. However, I don't know the slope. I have a reference line. If I find the slope of my reference line, then I can find the slope of my line. To do that, I just need to solve for y. This is 5y is equal to, subtract 2x from both sides of the equation and divide each term by 5. You notice that then the slope would be the coefficient of x. So the slope of my reference line is minus 2 over 5. The slope of my line would be negative and reciprocal of that. Negative and reciprocal of that would be plus 5 over 2. So now I know the slope of my line is 5 over 2. I can use these informations to write the equation of the line. I can use point slope formula, substitute for each slope 5 over 2, substitute for x1 and y1 is corresponding value, and we can multiply each term by 2 because I have a fraction here, distribute the 2, and then ultimately solve for y to get it into slope-intercept form. And as you can see, those two lines are perpendicular and the slope is negative and reciprocal of each other. Linear models and regression, when data points are plotted in x, y plane, the resulting graph is a scatter diagram or a scatter plot. Scatter diagrams are often helpful for analyzing trends in data. So in this example here, this is a predictions for net Medicare spending in billions of dollars. are shown in this table. So in year 2018 all the way to 2023, the cost is recorded here. Part A, we want to make a scatter diagram of the data. We're going to let x equal to 0 correspond to year 2018, x equal to 1 correspond to 2019, and so on. We want to find a linear function f that models this data, the graph of f, and the data in the same viewing window. Interpret the slope m. Use f of x for part C to estimate Medicare costs in 2024. So that's all we have here is these data collected each year. So what we can do in this case is to input the data. We can input this data on your calculator. The data points can be expressed as an order pair. So 0, 574, that correspond to the first year that we said x equal to 0 for year 2018. The cost was 574. So this would be 1 point. And for the second year, which corresponds to year x equal to 1, the cost is 642, and so on. So if you plot this number, as you can see, this would form like a very close to the linear equation, like a straight line. We can find the slope by picking two of these points. Any two would do. The slope would be equal to 57. We use y2 minus y1 over x2 minus x1. The point 0 and 574 indicate that the y-intercept b of the y-intercept is 574. So as you can see, this would be my b. So this, look, y is equal to mx plus b. So my slope is 57. So f of x then can be written as 57x, like mx, plus the y-intercept here is when x equal to 0, y is equal to 574. Graph of f reassigned as y1, and the data are shown below. So m is equal to 57 indicates the Medicare costs are projected to increase on average by 57 billions per year. Other formulas of f of x are positive. So for part C, the value x equal to 6 correspond then to year 2024. So if I want to know what would be the cost for year 2024, I just have to find f of 6, substitute for each x6, and then you can see I give you 916. So that would be that the Medicare cost could be reached to $916 billion in year 2024. We're going to use a graphing calculator to find the least squared regression line that models the Medicare cost presented in the previous example. I'm going to graph the data and the line in the same viewing window. So for part A, shows how TI-84 calculator, TI-84 plus, graphing calculator find the regression line for the data the year are entered into the list L1, and Medicare costs are entered in list L2. So you need to enter the data here in L1 and L2 line columns. And in figure B, the formula for the regression line is calculated by your calculator. So as you can see, this would be your slope and this would be your y-intercept. Note that the equation is not exactly the same as one found in f of x, but is pretty close. You can see the slope and y-intercept are very close to what we calculated. So both line and regression lines are graphed, as you can see in your calculator. The table represents the percentages of persons using smartphone according to different age groups and incomes for less than $50,000 and more than $100,000. So these are the data that we have, the age group between 25 years old to 34 years old. That would be less than $50,000 would be 60%, more than 100,000 would be 81%, and so on. So graph the data by using the income of more than $50,000 data for the X value and the corresponding greater than $100,000 data for the Y value, predict whether the correlation coefficient will be positive or negative. Does making more money at any age correlates to an increased likelihood of using the smartphone? And for part B, use a calculator to find the linear function f based on least squared regression that models the data. Graph of y is equal to f of x and the data in the same viewing window. And for part C, for people 65 years or older or over that, who makes less than $50,000, 16% use a smartphone, assuming that this age group follows a trend similar to that of the four age groups that listed in the table. Use your line function to estimate the percentages of those 65 or over with an income of more than $100,000. Use a smartphone. Compare your results with actual value of 42%. So in this case, the scatter diagram of the data is shown. Because increasing X value corresponds to increasing Y value, the correlation coefficient R will be positive. Within every age group, those making over $100,000 have a higher percentages of smartphone use than those making less than $50,000. So for part B, because y is equal to f of x, the formula for the linear function f that models the data is given by, okay, a calculator find that f of x equal to about 0.8021x plus 35.1657, where the coefficient has been rounded to the 4 decimal place. Graphs of the f and the data are shown. So the calculator would figure out my y-intercept and slope and would graph it for us. So for part C, because 16% of people 65 years or over makes less than $50,000 use a smartphone, we can use f of x to predict this percentage y for people 65 years or over who makes more than $100,000 by evaluating f of x, where x equal to 16. So we want to find f of 16 using that formula that we found. We substitute for each x 16, and that'll come out about 48%. So the value is more than actual value of 42%. We're going to continue our discussion on for chapter 1, linear functions, equations, and inequality. In this section, we're going to look at linear equation and inequalities. Linear equation and inequalities. An equation is a statement that two expressions are equal. To find an equation means to find all numbers that makes the equation a true statement. Such numbers are called solution or roots of the equation. A number that is a solution of an equation is said to satisfy the equation, and the solution of an equation makes up its solution set. So a linear equation in one variable is an equation that can be written in this form: ax plus b is equal to 0, where a is not equal to 0. Because if a is equal to 0, then we're not going to have any x here. Solving linear equation, an analytic approach in which we use paper and pencil to transform complicated equation into simpler one. And the second one is the graphical approach, in which we support our analytic solution by using graphs or tables. Addition and multiplication property of equality. For real number a, b, and c, if a is equal to b and a plus c is equal to b plus c are equivalent. What that means is we can add any number to both sides of the equation. We can subtract any number from both sides of the equation. We use this to isolate the variable. If c is not equal to 0, then a is equal to b, then also ac is equal to bc. That means we can multiply or divide any number to both sides of the equation. So let's take a look at this example. We have 10 plus 3 times 2x minus 4 is equal to 17 minus x plus 5. For those of you watching this later at home, now is a good time to pause the session and see if you can get the same answer. Looks like the first step is to distribute 3 and minus 1 here. Once I distribute the 3, I get 6x minus 12. And here, if I distribute the minus 1, I get minus 1 minus 5. And then we're going to combine like terms. 10 minus 12 will give you minus 2. And then if I move all the x's to one side, here I can add x to both sides of the equation. So we've got 6x plus 1, it should be 7x. So now I need to add 2 from both sides of the equation. You get 7x would be 12 plus 2, and then divide each term by 7. So x would be equal to 2. You can always check your answer by substituting for each x2. And see that makes sense, and it sure does. 10 is equal to 10. So x is equal to 2 is the solution. We can write it in the brackets as the solution set is 2. To solve for this, again, we have an equation involving fractions. One way would be to multiply each term by LCD. So here we have x plus 7 over 6 plus 2x minus 8 over 2 is equal to negative 4. Now, you look at the numbers here, and then you find the LCD first of all, right? So everybody agree that the LCD is equal to 6, right? Or 6 over 1. Do you have any problem with that? No, okay, we're good. So LCD is 6. So you multiply each term by LCD. So I have 6 over 1, 6 over 1, 6 over 1. So here we have 3 terms here. The first term is x plus 7 over 6 plus 2x minus 8 over 6 equal to minus 4 over 1. You see how we multiply each term by LCD? So this would guarantee to eliminate the fraction. So my next step would be eliminate fractions, right? So that would be, this is 2, not this is 2, sorry. So here it becomes 1, so that becomes 3. So the first term, what would that first term becomes? Just x plus 7, right? No fraction there. Plus. Now this becomes 6 over 2 becomes 3, so it would be 3 times 2x minus 8 is equal to, what is 6 times minus 4? Negative 24. So do you follow up till this point? You saw I got x plus 7, 3 times 2x minus 8 is equal to minus 24. Do you see that? Now, this equation here and this equation here is equivalent. They're same exact equation. Which one is easier to solve? This one, right? So, therefore, every time you have an equation involving fractions, that's what you do. You multiply each term by LCD to eliminate the fraction, and you get the linear equation after that. And then from there, you just distribute, right? That's pretty simple. You distribute 3, that becomes 6x minus 24, and then you combine like terms. You have 6x and 1x, that'll give you 7x. You combine 7 minus 24, give you negative 17. You add 17 to both sides, you get 7x equal to negative 7, and you get x equal to minus 1. Do you follow all the steps?
Yeah, but I learned better with that.
Sure. Do you follow how we got x equal to negative 1 though, right? Any question on that, anyone? Those of you following this live with me? Okay, so let's move on to the next example. So x equal to negative 1. Now, this is another example here where you have the equation involving decimal now. Okay, so let me again ask those of you watching this later at home to pause the session and see if you can get the same answer. Okay, so I have an equation involving decimal here. And in order to eliminate that, I can multiply each term by a factor of 10. Because I have 2 digits here after the decimal points, and so as the next 2, if I multiply each term by 100, I can eliminate the decimal. Look, if I multiply the first term by 100, this is what I get. If I multiply the second term by 100, this is what I get. 0.09 times 15 minus x, and finally 100 times 0.07 times 15. Okay, so here, this would give me what? 100 times 0.06 is equal to what? Just 6, right? 6x. Here, give me just 9 times 15 minus x equal to, now that would give me what? 7 times 15. Now, this equation here and this equation here are identical. Just one is easier to deal with because we don't have to worry about the decimal. So if you take a look at the steps, I get multiply term by 100. This is what I get so far. 6x plus, now I can distribute this. 9 times 15 is equal to what? 135. 9 times minus x is minus 9x. Equal to 7 times 15 is 105. Okay, once I get it to the linear equation, that's all I have to do, just combine like terms. 6x minus 9x equal to minus 3x. Then I can subtract 135 from both sides, becomes 30 on the other side, divide each term by negative 3, so x equal to 10. Okay, so this is really important. You may want to write this also in your summary sheet. If you have 2 lines that intercept at some point, this would be a situation, then you get one solution here, one point of intersection. If I have f of x and g of x that intercept at some point, if you graph from the intercept at one point, that you can say you have one solution here. If you have 2 lines that are parallel like this, they never intercept. So this would be a case where you get no solution. Okay. Or the last possibility would be when the two lines would be right on top of each other, like in this case. In that case, you get infinitely many solutions. So you either get one solution, no solution, or infinitely many solutions when we're looking at two equations like that. So the graph that we have here, the graph number 1 is y1 is equal to 10 plus 3 times 2x minus 4. And the graph of 2 here is 17 minus x plus 5. Okay. If you're going to use your graphing calculator to see if you get one solution, no solution, infinitely many solution, that's all you have to do is just enter these equations on your calculator, and the calculator would graph both of those on the same x and y axis and confirm that you only have one solution here. So intersection of the graph model, if you have f of x equal to g of x, once again, if you get to have a solution, you have to have intercept at one point. Other than that, would be either no solution with parallel line, or if you have the infinitely many solution with the same line. So if you write the equation in terms of y is equal to mx plus b, like in this example here, we have f of x is 5.91 x plus 13.7, and g of x equal to minus 4.71 x minus plus 64.7. So these two equations, if you go in and graph these two lines on the same line, you can see they have an intersection. So you do get a solution for this application problems. So if you have a second graph, f of x equal to g of x, and then in that case, you would get f of x minus g of x, and then you get an intersection for those two. So we're going to get some examples of x-intercept method here. Let's take a look at that. When you have the x-intercept model, the real number f of x equal to 0 corresponds to the x-intercept. So basically, when you let y equal to 0, solve for x equal to 0, and solve for y. Those are what we used earlier to find the x and y intercept, and that's exactly what we're doing here. So let's take a look at one example here. Using the x-intercept method to solve the equation here. Okay, so we have 6x minus 4 times 3 minus 2x is equal to 5 times x minus 4 minus 10. So what would be my first step here, anyone? Distribute, right? So the first step is to distribute. So you go ahead and distribute 6x minus 4 times 3x minus is minus. So in this case, I'm going to moving everything to one side of the equation before they distribute. So you would get to, if you go and use your graphing calculator, you can see at what point x would be a number when y is equal to 0. So at y is equal to 0, x equal to minus 2. Then this would be the case where you do have a solution. Or if you have a parallel line like that, then you would see there, or you could have infinitely many solutions here. In this case, for x and xy would be exactly the same. So in this case, when you have a linear equation, you could have one solution, always false or always true, depending on, again, looking at the graph of those two solutions. For inequality, we do the same thing. We are allowed to add any number to both sides of the inequality. The only thing you have to remember is if you multiply by a negative number, you change the direction of inequality to its opposite direction. So let's take a look at this example here. Here we have an equation involving, this is an inequality where we have to solve for x. What would be a first step here, anyone? Distribute. Okay. So we could distribute here 2x. Here we get minus 2 times 2x give you minus 4. Minus 2 times 4 give you negative 8. Okay, right at this point here, if I combine like terms, I get 3x minus 4x give me minus x, minus 8. So in this case, I'm going to, it's a good idea to move the smaller x where the larger x is located, so you don't have to come up with a negative coefficient. Like in this case, let me write it down here. Minus x minus 8 less than or equal to 2x plus 1. So if I move the smaller x, which is minus x where the larger x is located, by adding x to both sides of the equation, see what happens. So I get minus 8 less than or equal to, they give me 3x plus 1. So if I subtract 1 from both sides of the inequality, I get minus 9 less than or equal to 3x. So if I divide both sides by 3, see, I'm not dividing by negative now. They give me x is greater or equal to negative 3. See, because I moved the smaller x where the larger x is located, I didn't have to worry about switching the direction of inequality. In this example, in this side here, looks like they are moving the terms differently. They are moving 2x to the left. Therefore, you get minus 2x minus 1 give you minus 3x. And then you move the negative 8 to the right, then you get 9. Regardless, if you divide by negative, in this case, you have minus 3x less than or equal to 9. If I divide both sides by negative number, you have to remember change the direction of inequality to its opposite direction, and you get the same exact answer that we got here. X is greater than minus 3. Now, x is greater than minus 3. If you look at the number line, 1, 2, 3 is right here, negative 3. Greater than number 3 would be all the number to the right of minus 3. Remember how to write the interval notation? Make sure you know how to write the answer from set builder notation to interval notation. Would be all the numbers from 3. I'm going to use brackets here because the negative 3 is included. So it would be negative 3 all the way to infinity. That is the interval notation. That's a set builder notation. Sometimes I use x such that x less than or equal to negative 3 as being the set builder notation. But this is the interval notation. That's the set builder notation. Make sure you get yourself familiar with both notations, please. Okay, let's take a look at this one. We want to solve this inequality here. Here we have an inequality involving fractions. So the first step would be, if you choose to follow this step, is to multiplication by LCD to eliminate the fraction. So I'm going to pause the session. For those of you at home later watching this, I suggest you do the same and see if you can get the same answer. Zoom recording. All right, here we want to solve inequality. If you have an inequality involving a fraction, and remember we said when you do have that, you look for the least common denominator, right? What's the least common denominator here? Negative 3 or negative 3 over 1. Okay, so you multiply both sides by negative 3 or negative 3 over 1. Let's do that. Okay, so on the left-hand side, it's a good idea to not do this in your head, just actually write it down. You can see exactly what we're doing. On the left-hand side, you get negative 3 times this expression, less than or equal to, here we have negative 3 times x plus 2 over negative 3. Now, why we did that was because to eliminate fractions. So for my next step would be to reduce. So I get minus 3 times 2x minus 3 is less than x plus 2. So what's the next step? Distribute, right? So we distribute that. We get minus 6x plus 9 less than x plus 2. You see, this is a lot easier to what we originally had, right? This is a lot easier form to look at. You have a question? Yes. What we need to do is, because I multiply each term by negative 3, you were supposed to flip the direction of inequality to its opposite direction. You're absolutely right. So at this point, let's do that. So this was a less than, because I multiply each term by negative 3, everything has to be greater than now. Makes sense, right? Okay, now I'm going to move the smaller x where the larger x is located. So I don't have to flip again. So I can move 6x, negative 6x, I add 6x to both sides of the inequality. So let's do that. You get 9 greater or equal to, so in this case I get 7x plus 2. If I subtract 2 from both sides of the inequality, So I get 7 greater than 7x. I divide both sides by 7. So I get 1 here. Should point at that. So that means x is less than 1. So if I show that on the number line, if this is 0, and if this is 1, x is less than 1 would be all the number to the left or right of 1? Left, less than. So how will you write this in interval notation? You write minus infinity, comma, 1. Do I use brackets or parentheses? Parentheses, because the endpoint is not equal. It doesn't say equal to. Coding. Okay, so this is another example. We have inequality. We want to solve for x. Once again, let's pause the session, see if you can get the same answer. Okay, here we're going to distribute first. Okay, this is like -1 here. We distribute. So you get minus 3 times 4x minus 12x. That would be plus -3 times -4 would be 12. Greater or equal to 4 minus x. Then you can distribute it becomes plus 1. Okay, I have 4 plus 1, that gives me 5. So minus x plus 5 on the right-hand side. Left-hand side, we get minus 12x plus 12. All right, so now I need to subtract. Well, let's see. We want to move the smaller x where the larger x is located. That way we don't have to get the negative coefficient. We can do it either way. If I add 12x to both sides of the equation, okay, let's do that. Then I won't have to worry about the negative coefficient here. So let's add 12x to both sides of the equation. Then I get 12 greater or equal to 12x minus 1 will be 11 plus 11x plus 5. If I subtract 5 from both sides of the equation, so we get plus 11x is less than or equal to, that would be minus, what would be plus 7. Good. Divide both sides by 11, we're done. X is less than or equal to 7/11. So if I want to write this in interval notation, this is 0. Okay, so approximately 7 divided by 11 would be about 0.6. This is 1, 0.6 somewhere around here. Here is x is less than, so it would be to the left of that. If I want to write this in interval notation, I'm going to use the brackets here. 7/11. So it would be all the number from negative infinity to 7/11, and then I'm using the brackets here. That would be my interval notation. Okay, so the question is, what if I have my solution as x is less than or equal to 7/11, which is the same thing exactly. Still saying that x is less than 7/11, so both would be okay. Recording. So the graphing approach to solving linear equation, intersection of graph method of the solving of the linear inequality. Suppose that f and g are linear functions. The solution of f of x is greater than g of x is a set of all real numbers x such that graph of f is above the graph of g, and then the solution of f of x is less than g of x is the set of all real numbers that the graph of f is below that. So that would be graphically doing that. So if you look at this approach here, if you graph both of these on on your calculator, then you can see the solutions on as seen here. So this would be applying the intersection of graphing method. That would be one word problem here that you can explore. I will let you use your calculator to see if you can get these results. Again, each of you have a different calculator here. I suggest that you either refer to those graphing calculator posted in class or show me your calculator so I can show you how to do these. So you'll be able to do all these problems here using your graphing calculator using this method here. So x-intercept method here, so solving inequality using the x-intercept. So here we have a minus 2 times 3x plus 1 greater than 4 times x plus 2. So in this case, as you can see, you would see the intersection would be minus 1, all the one from negative 1 to infinity with the solution that would be below that. So this would be 3 examples that you can explore. Now would be a good time to pause the session, see if you can get the same results. So the first one would be all the number from negative 1 to infinity. And the second one would be all the number from negative infinity to negative 1. And the last one would be negative infinity to negative 1. We're going to look at more examples like that. So this one, if you have an inequality, if you have 5 plus 3x is between negative 2 and 20, if you want to solve this, here you need to isolate x. So what you do is, in this case, you would have to add a number to each side so you can isolate this 3x here. So in this case, I need to add negative 5 to each side of the inequality. As long as you don't multiply by divide by negative, the direction of the inequality stays the same. So if I subtract 5 from each side, I get negative 5, negative 2 would be negative 7. 2 minus negative 5 would be 15. And then here you get 3x. If I divide this term by 3, then I would see x would be between negative 7/3 and 5. You can write it in interval notation. The last section of this chapter explore some of the application problems here. There are some strategies that you can follow here. You want to, of course, read the problems carefully. You need to write the equation for the scenario that they're giving us and solve the equation and check the answer and see if it's reasonable. So if you look at the first example here, the dimension of television screen. Modern television often has 16:9 aspect ratio, the meaning that is the length of its rectangular screen is 16/9 times the width. If the parameter of the screen of the Samsung model having the ratio of 150 inches, find the length of the width. So in this case, in other words, if the width is x, the length would be 16/9x. That's what it means. So in this case, the parameter is equal to 2 times length plus 2 times width. So if the p is given to me as 150 and the length is 16/9x and the width is 2x, then basically just solve for x. Once you find x, you just multiply by 16/9 and that gives you the length, and the width is known as that. So we can always use our calculator also to plug the number in and to see what the intersection is, and that would be the solution. Now, this is another problem here that a lot of students have a problem with that, the mixture problem. So I'm going to spend a little time on this one. Okay, it says, how much pure alcohol should be added to 20 liters of 40% alcohol to increase the concentration to 50% alcohol? So those of you watching this later at home, now is a good time to write the problem down and see if you can imagine how to write the equation for this. Okay. The first step, we want to let X represent the number of liters of pure alcohol to be added. Now, it's a good idea to model this using these boxes here. So here it says how many pure alcohol should be added to 20 liters. So this is known, this is 20 of 40%. So 20 liter, this is the strength, 40%. Plus, okay, how much alcohol we're gonna add, and the strength for the pure alcohol would be 100% or 1. So when we add 20 liters plus unknown liter X, the total must be 20 plus X. And the strength, the concentration of the final product should be 50%. So basically, you would draw 3 boxes like that. 1, 2, 3. And here we know is 20 liter. The strength is 40%. Here I don't know how much we're going to add, but I know the strength here is 100%. If I add this 2, I should get this final result. Now the amount is pretty clear, 20 plus X. The amount will be 20 plus X. And the strength, it says I want to be 50%. For those of you following this live with me in class, everybody follow what we're doing so far? Okay. All right, the next is pretty simple. You just multiply 20 times 40% plus X times 100% is equal to 20 plus X times 50%. It just comes from here. So 20 times 40% plus X times 100% is equal to 20 plus X times 50%. That's my equation. The rest should be pretty simple. We can multiply each term by a factor of 10 to eliminate the decimal. If I multiply this by 100, I get 40, multiply this by 100. So I'm multiplying each term here by 100 to eliminate the decimal. And then the next step is to distribute. 40 times 20 would be 800. Distribute 50, you get 1000 plus 50x. And just simply solve for x. So x will be equal to 4. Therefore, 4 liters of pure alcohol must be added. So this is another word problem here where we can use this equation, the functions. Peripheral Vision Inc. produces high definitions DVDs of live concert. The company places an ad in a trade newsletter. The cost of the ad is $100. Each DVD costs $20 to produce, and the company charges $24 per DVD. So we need to express the cost C as a function of X, the number of the DVD produced. That's how you do that. So the equation, the $100 is fixed number, should add it to 20 times X. X is the number of DVD that you sell here. So the cost would be 20X plus 100. So the fixed cost of 100, and for each DVD produced, the variable cost is 20. So it'd be 20 times X. So if you have 1 DVD, it would be 20 times 1. If 2 DVD, it would be 20 times 2, and so on. But that $100 is fixed. So the cost, the equation for cost would be 20X plus 100. Express the revenue. Since the DVD sells for $24, the revenue R would be 24 times X. The number of the DVD you sell is X times 24, that would be your revenue. So find the value X, does revenue equal cost? So this would be my equation. When Rx becomes CX,
then 24x equal to 20x plus 100, and just simply solve for x. So x would be 25. We can also graph that and confirm that with your calculator. Now, one more type of word problem that you need to know for this section is the direct variation. A number y varies directly with x if there is non-zero number k such that. So if somebody says y varies directly with x, you would write y is equal to some factor k times x. So the number x is called constant of variation. So in this case, Hooke's law say that the distance y in the spring strength varies directly with the force F. If a force of 15 pounds, the strength of the spring 8 inches, how much will force 35 pounds would be? So I need to write down the formula. You don't have to memorize any equation here. That's all you have to do is just write down the variation here. It says y, which is in this case distance, varies directly with x. So it means y is equal to some number k times x. That's the first thing you do. The next thing is you have to solve for k. To solve for k, I need to know some initial condition. So I have to read the question carefully and see if you know an instance where the value of x and y is given to you. In this case, it does. They're saying that when y is equal to 8, x is equal to 15. It says if the force of 15 pounds stretches a spring 8 inches. So I have one condition. I know when y is equal to 8, x is equal to 15. I'm going to use this initial condition or given condition given to me to solve for k. Now here I know what k is. Once I know k, my equation changes to y is equal to 8 over 15 times x. I know what x is, or what k is now. So now I can solve for any other condition, which is like they're giving you here. It says, how much will a force 35 pounds stretches the spring? Okay, that's all I have to do is just plug the number in this formula. It's only one unknown here. The only unknown here that I know here is x, the y. So I know x is 35. So if it's x equal to 35, what is y? Because I know what k is, I can easily solve for that. Okay, so this is another word problem here. A trapezoid has an area of 169 square inches, height 13 inches, and the base is 19 inches. Find the length of the other base by solving the formula. So they're giving you this formula here. A is equal to 1/2 h times b1 plus b2. You want to solve for b1. Basically, when you have a formula in terms of multiple variable, what you do is you would treat the other variable as they were a constant, as though they were a number. Okay, so in this case, you have A is equal to 1/2 h b1 plus b2. Since you have a fraction here, I can multiply both sides by 2 to eliminate the fraction. If I multiply this side by 2 and this side by 2, you see I get 2a is equal to h times b1 plus b2. Okay. Here, if I divide both sides by h, I can eliminate the coefficient here. So it'll be b1 plus b2. Remember, we're solving for b1. So if I subtract b2 from both sides of the equation, I'm done. They give me 2a over h minus b2 is equal to b1. So that's how you solve for one variable in terms of the other one. And then if I give you the value for each of those, I can calculate for that. Solve each formula for what's given to you. So in this case, the first one we have P is equal to 2W plus 2L. You want to solve for L. Okay, so let's go ahead and do this step by step. The first step is to subtract 2W from both sides of the equation. Right? So here you get P minus 2W is equal to 2L. To solve for L, I have to divide both sides by 2. Here, that give me L in terms of other variable. Next one, you want to solve for F. Okay, I can multiply both sides by reciprocal of this number, which is 9 over 5. So this would be 5 over 9 times 9 over 5 times F minus 32. So we get 9 over 5C is equal to F minus 32. To solve for F, you would add 32 to both sides of the equation, and you get 9 over 5C plus 32 is equal to F. So I solve F in terms of other variable. So what I'm going to do is right now is erase all that and show you the steps on the PowerPoint. So everybody see how to see all the steps. So let's go ahead and take a look at the solution once again. So basically, you would treat the other variable as our number, and you follow pretty much the same examples that you did when you solve equations. Okay, so like I showed you, to solve for L, you would simply treat the other variable as it is a number. To solve for C, F in terms of the other variables, you can multiply both sides by reciprocal and isolate F like I showed you. This is another example here where you can use the functions. Grain bean in the shape of an inverted cone has a height of 11 feet and the radius of 3.5 feet. The grain is 7 feet high in the bin, and calculate the volume. Okay, so we need to look at the proportion here. We have 3.5, and this is the radius R, we don't know. The height is 11, so we can write the proportion for this. If you look at this R over H is equal to 3.5 over 11. Okay, we can use a proportion, and then we can go ahead and here solve for R by multiplying both sides by H. And then from there, we just substitute the values and we can solve for R. And then once you find the radius, you can go ahead and solve for the volume.